name is Aida. Me and my group members Nahid and Stefatul implemented Variational AutoEncoder on MNIST dataset. First, let's see what's the difference between AutoEncoder, which was covered in class, and Variational AutoEncoder. AutoEncoders learn the compressed representation of input automatically by first compressing the input and decompressing it back to match the original input. The encoder outputs the single value to describe each latent state attribute. The question is, what single value would you assign for the smile attribute if you feed in a photo of the Mona Lisa? Using a variational autoencoder, we can describe latent attributes in probabilistic terms. The reason why an input is encoded as a distribution with some variance instead of a single point is that it makes possible to express very naturally the latent space regularization. The distributions returned by the encoder are enforced to be close to the standard normal distribution. There are actually two parts that we need to change in order to convert autoencoder to variational autoencoder: the encoder and the loss function. As you observed in slide 3, in an autoencoder, each image is mapped directly to one point in the latent space. In a variational autoencoder, each image is mapped to a multivariate normal distribution around the point in the latent space. Loss function in an autoencoder only consists of the RMSE loss between images and their reconstruction after being passed through the encoder and decoder. In VAE, the loss function requires one extra component, the KL divergence. In a variational autoencoder, for a given input, each latent attribute is presented as a probability distribution. When decoding from the latent space, we'll randomly sample from each latent state distribution to generate a vector as input for our decoder model. Instead of just learning the function representing the data like autoencoders, variational autoencoders learn the parameters of probability distribution representing the data. Since it learns to model the data, we can sample from the distribution and generate new input data samples. So it is a generative model like, for instance, JANS. The encoder takes each input image and encode it to two vectors, MU that shows the mean point of the distribution and logvar that represents the logarithm of the variance of each dimension. These two vectors together define a multivariate normal distribution in the latent space. To encode an image in a specific point Z in the latent space, we can sample from the distribution using this equation. Lambda layer is responsible for sampling. Here, we require both RMSE loss and also one extra component, which is KL divergence. KL divergence is a way of measuring how much one probability distribution differs from another. In a VAE, we want to measure how different our normal distribution with parameters MU and logvar is from the standard normal distribution. We aim to implement a new neural network architecture called Variational AutoEncoder, which gives the capability of smooth learning of latent state representation of the input data. It is a challenge whether an image can be reproduced from the underlying probability distribution of the small latent space, and VAE comes forward to solve this problem. AutoEncoder takes too much computational resources. VAE reduces the dimension of each sample image and solves the problem of resource allocation. MNIST dataset is used as input, and we took 20,000 samples of this dataset to save some computational power. Here is the model that we designed. This is the encoder part, and this slide represents the decoder. The appearance of reconstructed digits are a little bit different than the original one having the same class. This difference appears because the reconstruction doesn't depend on the digit only, rather than the distribution that has been learned to VAE. The digits are also a little bit blurry. This is because latent vectors are too small. Actually, the Z-dime is 2. VAE can be used as a generative model. That means the model's decoder is capable of generating new images from the small latent space. So VAE is well known for generating fake images. Thank you.